I'm going to be talking a bit about the complexity of walking, indeed, because we've mentioned already a couple of times, like, with VR treadmills and all that kind of stuff, that I thought it was an interesting kind of topic to be talking about for virtual reality. So when I talk about walking, I mean, we all have seen the scene from Ready Player One with the VR treadmill, especially where the guy like really sprints at a certain point. I tried to get that clip, but I didn't find it in an easy format, so I'm just showing another one. But that is one of the reasons, at least, that that virtual reality in general could be interested in a proper walking implementation. And the main reason which I want to focus on is for it to increase immersion. There are other reasons why VR treadmills could be a thing, or walking in VR could be a thing. And for example, as a workout tool, some people might want to use it. It's often already being used as a simulation tool when you think about, for example, military applicancies. As a research tool is often being used as well, but that's then most likely related to, for example, some kind of neurological pathological disease that is affecting the gait of a certain person, for example, in Parkinson's disease, that is the case. So if you can estimate the typical gait of such a person, that could help in diagnosis, or that could help in a certain treatment pattern as well. And of course, you can ask yourself the question, doesn't it kind of exist already in the virtual world? And yes, it does. Like we have, for example, the Virtuix Omni. This was founded originally by Jan Goedgeluk. He's from Belgium, he's from Ghent actually, but he lives in the US now. And the concept of this was kind of like a frictionless bowl with inertial sensors. And they had a Kickstarter that ran in 2013 that was eventually funded for $1.1 million. So wow. A very successful Kickstarter. Yeah. And they received an additional $20 million from investors. Wow. And they actually started indeed with production, because I mean, this was a very expensive piece of kit, which was also one of the problems. I'll come to that probably later. But the actual production started in 2015, and the shipping of the actual Virtuix Omni started in 2017. However, mid-2017, they decided to go commercial only, and I believe they have now a contract with the military, the U.S. military, as much more of like a simulation tool rather than like the gaming kind of tool that it was supposed to be in the beginning.
Smart.
I'm having trouble focusing. I'm just imagining a giant box of Cocoa Puffs that I just pour into that bowl and I eat with. Continue.
I've tried. I've tried an Omni.
I was gonna say you tried eating cereal out of an Omni. What?
I probably would have had a better experience had I done that.
Bowl scrapper, right?
I was hopefully I don't step on your toes here, Rowdy, but I was very excited about treadmills until I tried one. Because the feeling isn't natural. If you imagine as a kid, like if you've ever walked on a hard floor with socks on and you slide around, that's kind of what it feels like in a bowl. Mm-hmm. And imagine trying to play a VR game with that sensation underneath your feet.
It's so weird.
It's just weird.
I've done the same. It's so weird. It's like, it feels, especially when you don't lift your legs. You're just you're just sliding back and forth. It feels exactly like that, like as if a big, giant is holding on to you, and you're just sliding back and forth.
Yeah,
totally alien.
It's true.
But that wouldn't be different for the army, though. They would have the same experience, right?
Yeah, but the army spends a lot of money on a lot of crap, so.
Yeah. The thing is, with this was supposed to be a gaming device for like a wide variety of games. Yeah. Well, what they're doing now with the army is probably a very tailored experience, specifically for the kind of application that they're using it for. So not an uncontrolled environment anymore, which is a big thing, of course, and I'll come to that later.
So what do they do with the military? Are you saying that the project forked away from consumer target and went military?
Yeah, so I don't know if they went military only. No, they didn't went military, or they went to arcades a lot. So they went to several arcade applications, but also they have a contract, I believe. Well, I don't know which military it is, but I found online that they had a contract with the military as well. Mm-hmm. Mm-hmm. The next was a kind of like a competitor as well, was the Cybrid Virtualizer. This one was founded by, I'm sorry if I raped the name, but it's Tunke Chakmak in 2013. And also here the concept was, again, a frictionless bowl with integrated motion sensor. The concept is a little bit different since it's not like the bowl shape and you have to do it on your socks. But this Kickstarter was also funded in 2014. This was funded for $361,000 and 450.
Wow. This one created a lot of buzz on YouTube. Like I've seen so many videos where they were playing GTA, Skyrim, so many far back titles. It's crazy.
But it gets a little bit darker from here on because there is no delivery date as of yet. So people who bought it, at least as far as I could find, have not actually received their order yet. However, in 2016, they became exclusive to commercial customers. And in 2019, they have already delivered the second generation for commercial customers only. And people are pretty pissed. There's even like some Facebook groups that are trying to call them out in order to get their money back. But so far as I know of, that has not occurred yet. So yeah, it's strange though that they have already a second generation for
so they have been waiting for 5 years now then?
Since the successful Kickstarter, yes.
Yeah.
Yes.
Wow. Okay.
Wow. Yeah.
Well, there's already actually a second generation, but only for commercial customers. Yeah. Strange. And then there are others. We have Cat VR. We have the Infinite Deck. And we have the WizDisc. If anyone remembers that one, it's a rather strange one.
The WizDisc?
Have the WizDisc,
I remember
Rover WizDisc, I think it's called. This with the disc that like shakes around like that. It looks really weird. All of them have like a little bit of a different concept, but it all comes down to the same thing, that it tries to simulate walking, but only walking, not more than that. There's some jumping maybe involved in that, but it kind of highlights why this doesn't work. Is one, the barrier of entry. It's far too high in order for it to convince people to go and buy something like this in order to get onto that. And second is that the general experience with these kind of things is it has a learning curve. Like you need to learn how to walk on these things. And that is not something that we're used to with walking, for the very reason that it's such a natural thing that we do. It's something that we do pretty much every day. Normally you do it every day. And to have some device trying to simulate that experience is really weird. And that is also the reason why I always say, like, I don't believe that the current technology allows for us to have a treadmill that delivers a satisfying experience. And the reason for that is the next topic is what is walking actually? If you think about the core concept of walking, I'm going to dive a little bit further into this.
That's a good one.
I've got the answer. Phone works.
Okay.
Insider joke for anyone who follows the podcast closely. Yeah.
The thing with walking is that it looks very easy. You know, everyone does it. Everyone is walking through cities, parks, shops, forests, and most of us just do it. We don't even
we just do it.
About it.
Yeah, we do it.
Yeah, it's true.
It is. It's just a little funny when you mention it like that. It's almost like.
But if you give it some more thought, we're rarely just walking. You know, during walking, which is mainly a motor task, we often perform another task, which is mostly cognitive as well. While walking, for example, we occasionally talk to the person that's walking next to us. We think about what to buy next in the store. We step over tree roots because we see them as an obstacle and we avoid them without any effort. We don't even think about doing that. You know, we don't walk and all of a sudden run into a building.
As long as you see it, of course. Right.
As long as you see it or experience it in any way or form.
Yeah.
And such a simultaneous performance of two tasks that is called dual tasking. So I know that multitasking, nobody really can do that because it's often related to two cognitive tasks. But if it's a motor task and a cognitive task, we are able to do those two things together without even thinking about it, because we have a separate area in our brain for motor and tasking, and a separate area in our brain for cognitive.
This is absolutely the part of the podcast where it would be great to have a woman on. Be like, you're all men. You can't multitask.
Yeah.
I can. Yeah.
Yeah. So, although we often take for granted that we are able to do this, it actually requires some very complex neural mechanisms. And there are several operations that are involved during human gait, such as the activation of the central nervous system, the transmission of signals to muscles, contraction of these kind of muscles, sending back sensory information, sort of feedback mechanism that indeed says that the movement has been performed. And the way that this all happens is all for us completely unaware. We're completely unaware of that happening, and it even appears to be quite stable and quite smooth with regular and repeating movements. But that is not really the case. It's not as smooth or as stable as it might seem, because there is a certain factor of chaos into that as well. And I'll come to that right now. So if you, this is probably the most complex part of the presentation, but it's just a core concept that I'm trying to give here. I'm not going to go fully into the physics, because it's also not my line of work or line of experience. The neuroscience part I kind of already explained, but this is like the physics parts of walking, and a lot of that comes from the double pendulum, and that is a system or a physics strategy that is kind of explains how walking occurs. So during forward movement, the leg that leaves the ground then swings forward from the hip, and this first sweep is called the first pendulum. The leg then strikes the ground with the heel, rolls through to the toe, and that is a motion that is described as the inverted pendulum. The motion of the two legs is then coordinated so that one foot or the other is always in contact with the floor. So in walking, what actually happens is that your body kind of vaults over the leg on the ground, raising the center of mass to its highest point as the leg then passes the vertical axis of your body, and then dropping to its lowest, again, as the legs are spread apart. And essentially, this means that it's a constant conversion from kinetic energy or forward motion that is constantly being traded in for a rise in potential energy. And that is the concept of the double pendulum. And my physics lab actually has a very nice kind of way of illustrating the element of control and the element of chaos into that as well. I'll quickly switch to that as well, because it's running over here.
Please cover your children's eyes before this segment.
So what you see here is basically the double pendulum in action. With a little bit of imagination, you can imagine a leg that is moving forward, and they have like some very nice graphs on this as well. You can see that it's a fairly controlled kind of movement with the synograph that is being generated constantly, and there's a certain pattern that is being repeated the entire time. We can see that here as well, that there's a pattern that is being repeated, but we also see that this pattern is not always exactly the same. And that is also the case with our gait, that there's a certain element or a certain factor that is not always as smooth as it actually appears like. Now, when we go back to this double pendulum, and we just change like a few of the parameters, you can do that really nicely on here as well. Then what you can see that you rather quickly can generate like something similar, but it turns into complete chaos just by changing some factors. And this is the kind of thing that I think is very interesting, that this is a very, very strictly controlled kind of system that allows us to perform this kind of movement, because it's going completely mental right now for the audio listeners.
That's full gadgeteer right there, I'm telling you.
Yeah, exactly.
Full on gadgeteer.
So you can see here as well, like there is still a pattern that is available, like it's still a certain pattern that is emerging, but it's not exactly going to be the same kind of thing. And we can see it indeed when we look at the pattern here that is being developed, is that it's completely out of control, which I think is rather interesting.
So you're saying our knees could do this?
Our knees could do this in your world. So.
I would just love to be the person who tuned in like 30 seconds ago and goes, "The feck is going on? Like, what is with the swinging balls and the sketch chart and like what's happening here right now? I have no idea."
But we're not there yet. So I've already said that it's rather complex, but it's really complex. Like because we also have the neuroscience part that is involved into this, and the actual neuroscientific part that is involved into this is the primary motor cortex, or Brodmann area 4, and this is a brain region that in humans is located in the dorsal portion of the frontal lobe. Now this primary motor cortex is kind of defined anatomically as the region of cortex that contains the large neurons. These are known as the Betz cells.
Sorry, what exactly are we looking at here? Because that looks like some kind of like Salvador Dali painting.
Yeah, it's kind of like a funny representation of like if you take the motor cortex of your brain.
That's the
I
brain.
believe it's called a conundrum. I believe a cununculus. It's called a cununculus.
Cununculus?
Yeah,
we could have called it the oculus
cununculus.
or the cununculus. I would have preferred cununculus personally.
Reminds me of Sim's concubines.
So what it basically does, it highlights the motor area, but every part of the motor area has a specific region that it kind of controls in your body. So we have the trunk, the neck, the head, and this is actually, if you would shut down these areas, then you would get a shutdown of those kind of areas kind of as well into that specific area. And the way that they represent it often is with these kind of like images in order to also show like how important certain areas are. As you can see is that the hands are enormously big because there's so much sensory information, so much motor control going into those kind of like, you know, physical movements. And you see like the trunk, the neck, the head, the shoulder, and the arm are all located in the same area. While it's a fairly large area, there's not that much because there's not a lot of motor control in there either. The same goes for the elbow, forearm, the wrist. It's all fairly junked together. But then again, the eye, the nose, the face, and the lips were very somatosensory, very important. They get very much highlighted there again.
Does this question for you? Does this diagram essentially represent that there's a part of the brain that's controlling these various bits, and for instance, why people who have taken some kind of trauma to the head oftentimes would end up losing motor control of those bits of their face areas. Kind of altogether, or is it?
Yes.
Okay.
Yes. So that can indeed be caused by that. Also, when one side of the face shuts down, that could also be because it's like, for example, the left side of your brain that is has a problem there. So that's the Brahman area 4. Now, I was talking about these large neurons, and these large neurons, they send down the axons to the spinal cord, all the way to the synapse of the spinal cord, and then onto the alpha motor neurons in the spinal cord, which then connect to the muscles. So it's a signal that's being sent from your brain all the way down through the spinal cord to your muscles to then activate the motion. And that's the only thing that the brain actually really does, is activating the motion and stopping the motion. Because as soon as you're in motion, you have the double pendulum that keeps on like moving itself forward. So that's actually an automatic kind of thing that happens. So walking does not just involve the lower limbs. The movement can be seen all the way down to the spinal column. And when you walk, your brain is doing this without its awareness all of the time. The system even works fairly well when you're blindfolded, which I think it's a crazy thing. Now, it's actually, I've said it's rather complex. It's really complex. It's actually so complex that robots can't even do it yet. Because we've all seen this movie, like with Boston Dynamics, where they kick a robot and it like stumbles backwards and it tries to recover from the punch. Now these kind of things are being developed, and it looks very scary because it's such a natural human thing to see. But there are so many parameters that have not been implemented yet. For example, like
in December, you're right. It's absolutely natural to see a man kicking a reindeer. It's pretty common around these parts.
Yeah.
It's a Scottish thing.
Exactly.
Yeah. It's
But there are a lot of parameters that need to be implemented, like, for example, obstacles, inclination, the type of underground that you're walking on, the speed that you're walking on, the temperature of that underground, the material that you have on your feet, or if you're doing it bare feet, the weight that you're having, and many, many more. And this is exactly the reason why I still don't believe that treadmills are a thing, even in Ready Player One, because there are certain aspects that are just going to be very, very hard to simulate. And I don't know yet how anyone would do that. Although I applaud all of the people that are making virtual reality treadmills and believe they have the success formula, because that's the way to move forward. You need to fail a lot in order to find something that will finally succeed.
What if they made a surface that was a bit like walking on raw steak? It would be better than these slippery surfaces.
Yeah, there are people now working as well, I believe, on like certain kind of cushions that can become harder and softer, can like simulate stairs, can simulate an inclination. And those kind of things that are probably more likely to succeed, because as soon as one of those parameters is off, for example, if you're walking down a hill in VR and the inclination is not there, your brain will immediately say like, this is not right. And it will break the immersion. It might make you motion sick. I don't know, but are those kind of things like the underground feels different, the obstacles are not really there when you walk through, those kind of things can really break the immersion. So yeah, and then I finally still have some references for people who might want to read onto some more kind of very interesting stuff. It is a very interesting topic. I try to keep it like, as simple as possible. But there's a lot of stuff that even I have no idea about it, especially with the double pendulum. There's like entire research papers that have been written about that, because it's a mathematics and physics concept that is very interesting, especially when you want to go into robots walking. Yeah.
Huh. It's interesting. I wonder if Roddy, thanks. That's really cool. The double pendulum effect is something that I wasn't very aware of. Some animals obviously have their double pendulum happening forwards like us and backwards like, I don't know, a deer or something like that. Do you know, does that have any effect on it, or is it essentially the same thing just reversed? With the knee facing like the opposite direction.
The shape of the human body is not made to walk upright. That's why so many people at a later age get back problems, because our backs are not constructed like that. If you would let an engineer build our backs, it would look completely different, because we're not made to walk upright. That's also why children take such a long time to learn it. But the way that it works for animals is, I actually have no idea. But the thing is that the double pendulum is something that is being generated from the entire body that is actually vaulting over to the vertical axis.
Yeah.
So
the way I kind of see it is, or the way I think about it in my mind, is that we would sooner get a device that is attached to our brains, like a neural link, like that Elon Musk is working on now, that would somehow simulate the feeling of walking just through our brains, than someone will invent a good enough treadmill to convince us that we're walking on something naturally.
But the way that I see the neural link is still the other direction. It's like picking up signals from your brain rather than sending signals to your brain, because that would have to, as far as I know, it would have to be an invasive procedure, or like with some kind of weird magnets trying to stimulate some kind of cells. I don't see that happening either, just because of the fact that it would require the technology would have to change, of course. That's always the thing.
So that would bring us to the rocket shoes then.
Yeah, I'd love to see those with a double pendulum.
Yeah, I know.
Oh God.
So basically the question of how to walk in virtual reality is still an unanswered one.
Yeah, it's definitely, I don't think there's currently that the technology is there in order to make a treadmill or any form of locomotion that is capable of delivering a satisfying experience. Yeah, there are ways. I'm not saying that, like, for example, if you just want to do a stroll on the park on an even surface on asphalt, and it's just they can make a treadmill for that right now. But if you're saying I want to play Battlefield and I want to run through the grass and I want to then like slide on the ground and like shoot 3 people down, jump over a ledge, and like, no, that's just not there.
Yeah. You just fused 2 things in my brain. It was a very uncomfortable experience, but I'm going to share my eureka moment. Smooth locomotion. Segway. It exists in real life, lads.
Yes.
But people are asking, if you made a comment about, so Megan was saying, so if not upright, how would we be expected to walk? I think what was your point about the whole kind of ape thing where you're not meant to be standing upright?
Yeah.
So on all fours?
To walk on all fours.
Yes. Walk on all fours.
Yeah, that's what we were originally made for. Yeah.
Maybe
our backs are designed for that as well.
That we could walk on all fours, we'd be happier.
We still have, I mean, I haven't read the recent literature on it, but the last thing that I knew, or the last thing that I read about it, is the reason why we actually stood up was because our frontal cortex got developed so much that we could start using our hands for using different kind of tools.
Complex tasks in front of us,
Complex
etc.
tasks, yeah. The thumb is the reason why we walk up straight.
So if you want the TLDR, is the VR treadmills suck.
Yeah, that's what I tried to say in like about 20 minutes.
And it's gonna be very difficult for them to crack that nut.
That Picasso was particularly good. I like that. That was good. Might get a copy of that for my wall.
Yeah, but the thing is, like, I'm not trying to demotivate inventors or developers from trying new things, because it's only by trying new things that we eventually achieve something like that. But I do think that the current technology is limited in a way of delivering an experience that we all expect.
And something else I also learned is that basically Wade Woods got motion sick. He was like motion sick the whole movie.
Really?
Yeah.
Wait, you mean in filming it?
Because it was flat the whole time and he was running up and down stuff, so it must have been. Yeah.
Ah, yeah.
It was all lies.
Yes.
All lies. Well, thank you, Rowdy.